Hi, my name is Chris Rogers with Silver Peak, and in this video I'm going to demonstrate Silver Peak's Dynamic Path Control feature. Dynamic Path Control, or DPC, is a key Silver Peak feature when building a software-defined WAN. Building an SD-WAN entails creating an overlay fabric running in software over the top of a physical network. A true SD-WAN enables efficient management of business policies for any application across any type of connection to any location in your network. Silver Peak's SD-WAN fabric, called Unity, unites policy control, visibility, data security, and optimization of all your network traffic. Silver Peak appliances deploy transparently and will ultimately help you to lower the cost of your WAN. The setup for this demo is simple. We have a hybrid environment with a remote branch connected to a corporate data center via an MPLS link and an Internet link. Without Silver Peak, it would be quite typical for the MPLS to be used as the primary connection, while the Internet would merely be used as a failover circuit. Now, let's go to the demo. Looking at the deployment screen on the Silver Peak branch appliance, we can see it's configured in dual home mode. In this mode, both the WAN and LAN ports are configured with their own IP addresses to be used as termination points for our MPLS and Internet connections. The Route Policy screen is where we configure our dynamic path control policies. We can use a variety of match criteria in configuring our policies, but in this demo we'll use application type to enforce basic policies for SSH, CIFS, and FTP traffic. For our demo, SSH traffic will be automatically optimized and configured to always prefer the path of lowest latency, which will usually be the MPLS circuit. This is an example of dynamic path control using real-time health information to intelligently route traffic. A policy like that can be handy in protecting against latency spikes and network brownouts. CIFS traffic is automatically optimized and configured with a path preference of LAN 0, the Internet path. This means that CIFS traffic will be directed to the Internet path as long as it's up and active. Lastly, our FTP traffic is configured to be optimized and load balanced across all available paths. DPC will balance traffic based on real-time throughput on available links. FTP traffic will therefore be distributed to the link with the lowest utilization. Before we move traffic, I want to point out the current flows page. We'll use this page to observe traffic in real time, and this will give us information to assess the enforcement of the DPC configuration. We'll start by establishing our SSH session. We'll use PuTTY to connect to the data center Silver Peak appliance via the SSH protocol. With the SSH session active, we can now see the session in the current flows table, and we notice it's traversing the MPLS path as expected. Putting the SSH session aside, let's connect via CIFS to our data center file server. We'll copy a large file to get some traffic flowing. Refreshing the current flows table again, we see the CIFS session is up and active and being optimized. You'll also notice that the CIFS session has been directed to the Internet path per policy. This is an immediate indication that DPC is working and moving traffic simultaneously across both links in our environment. Now we'll establish the first of two FTP sessions to a data center FTP server. And again, we'll transfer a large file across the FTP session to see data moving. Refreshing the current flow screen, we see that the FTP session is using the Internet for its data transfer. Now I'm going to initiate an additional FTP session and again get some traffic moving across that session. This will allow us to observe the behavior of the dynamic path control load balance policy. Refreshing the current flow screen again, you can see that the second FTP session has actually been placed on the MPLS connection. This is a clear example of how DPC is used to balance traffic across multiple links in an active-active configuration. Bottom line here is that DPC enables you to use all the bandwidth that you are already paying for. Now let's simulate an Internet disruption. We'll do this by administratively bringing down the Internet link. You can see here that the Internet connection is now marked as down. Refreshing the current flow screen again, we can see the change in routing caused by the Internet outage. Notice that all our sessions are all still optimized and are safely traversing the MPLS link, since it's the only path currently available. Finally, we'll restore the Internet connection, making it once again available for traffic distribution. Gradually, DPC will redistribute flows using both the MPLS and Internet paths. This concludes our demo of dynamic path control. Now that you've seen DPC in action, if you'd like to learn more about DPC and the Silver Peak Unity SD-WAN fabric, please head over to our website at www.silver-peak.com. Thanks very much for watching.